Right now, above your head, there are 200 billion trillion stars, more suns than grains of sand on every beach on Earth. Most have planets. Trillions of those worlds could hold water, warmth, the ingredients for life, circling quietly in the same kind of orbit that once gave rise to us. By every number we can calculate, the universe should be crowded, loud with signals, busy with neighbors. And yet, for over 60 years, we've aimed our telescopes at the sky and heard exactly one thing: nothing. Total silence. That silence isn't an accident, and it isn't empty. It's hiding an answer. Tonight, I'll show you the explanations scientists actually take seriously and why each one is more terrifying than the last. Now get yourself comfortable, hit subscribe. We begin. Let's start with what we actually know, because the mystery only becomes real once you feel the size of it. Our home galaxy, the Milky Way, holds somewhere between 100 billion and 400 billion stars. That range alone should stop you. Not because it's large, but because it's so large we can't even pin it down to the nearest few hundred billion. Try to picture it another way. If you sat down tonight and tried to count those stars out loud, one every second, without ever sleeping or stopping, you would still be counting after 3,000 years. And that is only the low estimate. Reach the high end, and you'd be counting for well over 10,000 years, longer than all of recorded human history. And that is one galaxy. Beyond ours stretch more, hundreds of billions of them, by careful counts, and by some estimates, as many as 2 trillion galaxies scattered across the observable universe. Every faint smudge in a deep telescope image, every speck you might mistake for a single star, is often something else entirely, an island of 100 billion suns, so far away its combined light has faded to a whisper. Now, multiply. Stars in a galaxy, times all the galaxies we think exist, and you arrive at a number that quietly stops meaning anything. Somewhere around 200 billion trillion stars. A 2 followed by 23 zeros. By most estimates, that's more suns burning in the sky right now than there are grains of sand on every beach on this entire planet. Hold that in your mind for just a second. Every grain, on every coast, in every hourglass. And the stars still win. For most of history, we could only guess whether any of those distant suns had planets of their own. Then a small NASA space telescope named Kepler spent years staring at a single patch of sky, watching for the faint rhythmic dimming that happens when a planet crosses in front of its star. What it found rewrote the odds. Planets are not rare. Planets are the rule. There are more planets in our galaxy than there are stars. Rocky, Earth-sized worlds turned out to be common, not cosmic accidents reserved for us, but ordinary furniture in almost every system, and the most important number of all. Based on Kepler's data, our galaxy may hold tens of billions of potentially habitable planets, worlds the right size, at the right distance, where liquid water could pool on solid ground. Let that land personally. If you divided just the most cited estimate among everyone alive today, that would be roughly 5 Earth-like worlds for every single person breathing on this planet right now. 5 each. So here's the contradiction, laid out plainly. Given numbers like these, life somewhere else in the cosmos stops feeling like a wild hope. It starts to feel like simple arithmetic, less a question, more an expectation. And that is exactly what troubled a physicist named Enrico Fermi. One afternoon in 1950, walking to lunch with colleagues at Los Alamos, he asked a question so simple it has haunted science ever since. Where is everybody? His colleagues understood instantly what he meant, even though he'd said nothing about aliens at all. He was pointing at a hole in the math, and the deeper you follow his reasoning, the colder it gets. Because it isn't only about space, it's about time. Our galaxy is roughly 13.6 billion years old. Our solar system, the Sun, the Earth, all of it, is only about 4.5 billion years old. Sit with that gap. For 9 billion years before our Sun ever ignited, This galaxy was already here. Stars were being born, living out their lives, dying, and seeding the darkness with the raw material for the next generation, over and over, long before Earth was even a cloud of dust, which means something unsettling. If intelligent life arose on other worlds during all that time, some of those civilizations could be older than us, not by centuries, not by millennia, but by 1 billion years or more. Think about what humanity did in just the last century, from the first powered flight to standing on the moon to machines that think. Now imagine a head start of 1 billion years. And here's where the silence turns from strange to almost impossible. In 2013, 2 researchers at Oxford, Anders Sandberg and Stuart Armstrong, worked through the physics of spreading across the stars. Their conclusion was that a determined civilization, using only the resources of a single planetary system, could colonize the entire Milky Way, every corner of it, in just a few million years. A few million years sounds enormous to us, but hold it against the galaxy's true age. If you compress the whole 13.6 billion year life of the Milky Way into a single 24-hour day, then crossing the entire galaxy would take about 20 seconds. Less time than it takes to read this sentence aloud twice. So the galaxy should already be settled, or visited, or humming quietly, with the signals of 1,000 older civilizations going about their business. It isn't. Scientists don't like leaving a mystery this large unmeasured. So in 1961, an astronomer named Frank Drake sat down before a small meeting and wrote out a way to organize the whole question. A single line of multiplication, now known as the Drake equation. It doesn't give you an answer. It gives you the ingredients of an answer. How many stars form? How many have planets? How many of those planets grow life? How many of those grow intelligence? How long such civilizations survive? Here's the trap hidden inside it. The first ingredients we can now fill in with real data. Kepler handed us the planet numbers directly. But the later ones, how often life begins, how often it becomes intelligent, how long it lasts before it vanishes, we can only guess. And we're guessing from a sample of exactly one, ourselves. And that's what makes the equation so haunting. Feed it hopeful numbers, and it tells you the galaxy holds millions of civilizations. Feed it cautious ones, and the very same equation tells you the number might be less than 1. The same formula. 2 answers that could not be further apart, and no way yet to know which is true. So we stopped only calculating, and we started listening. Since the early 1960s, we've swept the skies for signals, beginning with Drake's own experiment, Project Ozma, when he pointed a radio dish at 2 nearby sun-like stars and waited. The logic was sound. A message from a technological civilization should give itself away. It would be narrow and precise in a way nature almost never is. A clean tone where the cosmos only offers static, a pattern that repeats, a signal that carries the fingerprint of intent. We have been listening now for more than 60 years. The confirmed count of genuine alien signals stands at 0. There was one moment, one night that still makes the hair on your neck stand up. Picture a warm evening in Ohio, August 15th, 1977. A radio telescope called the Big Ear, a flat metal structure the size of 3 football fields, is quietly scanning the sky on its own, printing its readings onto stacks of green and white computer paper. No one is watching in real time. The machine simply listens and prints and listens. Days later, a volunteer named Jerry Amon is sitting with those printouts, running his finger down columns of numbers. Most of it is the ordinary hiss of the universe. Then his finger stops. There, in the direction of the constellation Sagittarius, the machine had caught something. A narrow, powerful burst of radio energy, sitting almost exactly on the frequency SETI scientists had always believed an alien signal might use. It rose and held and faded across the full 72 seconds the telescope could see it. It was 30 times louder than the background sky. Eamon didn't have words for it. He grabbed a red pen, circled the reading, and wrote one thing in the margin. Wow, that printout still exists. The ink has faded, the word is still legible, and in nearly 50 years of trying, with instruments far more sensitive than the Big Ear ever was, the signal has never come back. Not once. So what was it? For decades, no one could say. But here's where the story turns quietly, away from what we might hope. Between 2024 and 2025, a team led by astronomer Abel Mendez went back into the archives and proposed a natural explanation. Their idea is that a cloud of cold hydrogen gas out in the galaxy was briefly, violently lit up, supercharged by a sudden blast of radiation from something like a magnetar, the dead, hypermagnetic corpse of a star. For a few seconds, that ordinary cloud could have blazed on exactly the frequency we watch, mimicking the one thing we've been aching to hear. It's a compelling explanation, but even the researchers are careful. As Mendez himself put it, the study does not close the case. The most famous hello we ever recorded may simply have been the universe clearing its throat. Now, before you decide we simply haven't shouted loudly enough, that we've been passive listeners who never announced ourselves, consider what we've actually been doing for the last 100 years. We've been leaking. Every radio broadcast, every television transmission since the early 20th century has spilled outward from Earth at the speed of light, an ever-expanding bubble of our voices, our music, our news, radiating into the dark. It sounds like a grand announcement. It sounds like we've been screaming our presence into the cosmos for a century. Here is the truth of it. That bubble of everything we have ever broadcast is about 200 light-years across. Our galaxy is 100,000 light-years across. So shrink the entire Milky Way down to the length of a football field, about 100 meters, end zone to end zone. On that scale, the full reach of every signal humanity has ever sent would be a tiny circle at the center about the width of a dinner plate, 20 centimeters, around 8 inches. That's us. That's the whole of our cosmic shout, on a field the size of a galaxy. And it gets quieter still. A radio signal doesn't travel like a laser. It spreads, and as it spreads, it thins, its strength dropping off with the square of the distance. Double the distance and the signal becomes 4 times fainter. It's the same reason a whisper across a room reaches you, but the same whisper across a stadium is swallowed whole. By the time our loudest broadcasts have travelled even 100 light-years, they've faded below the natural radio hiss of the universe itself. Undetectable, gone. So here is the collision. The single contradiction everything in this story has been building toward. The math says they should exist. The clock says they had the time. The galaxy says it could be crossed in a blink. We built the instruments. We aimed them at 200 billion trillion suns. We listened for 60 years. Nothing. Silence. And that exact contradiction is one of the deepest, strangest puzzles in all of science. It even has a name now, the Great Silence. On one side, a universe that by every number we can measure should be teeming with company. On the other, a sky that answers our every call with nothing at all. If you felt the weight of that as we walked through it, the numbers demanding life, the silence refusing it, then you've understood something most people never stop to feel. This isn't a failure of our telescopes. It isn't that we haven't looked hard enough or long enough. The searching has been real and careful and vast. The silence is not an accident. The silence is data, and it is telling us something we do not yet understand about the universe or about ourselves. We are, in this moment, a single lit window in a house so enormous we cannot see the far walls. We've turned on our light, we've cooled down the hallway, and we're standing very still, straining to hear a door open somewhere in the dark. No door has opened. So what do we do with that? We have two facts that refuse to sit together, and we are forced to ask which one is lying to us. Maybe the silence means exactly what it seems to mean, that something is out there, hiding or unreachable, or long dead. That's frightening enough on its own. But there is another possibility, a quieter, more personal one. What if the numbers themselves are the illusion? What if all those billions of habitable worlds are real, and yet almost none of them ever wake up? What if the leap from a lifeless rock to a living, thinking world is so staggeringly rare that we are not one voice among millions, but very nearly the only voice there has ever been? Because if that's true, the silence stops being a puzzle to solve. It becomes a warning about how fragile we are. It would mean this small blue world and the minds it somehow produced are not ordinary at all. It would mean we are holding something almost unbearably precious, and we would have absolutely no idea how it was made, how easily it could be lost, or whether it can ever happen again. To understand which of these is true, we have to go back further than any telescope can see. Back before the first signal, before the first civilization, before the first living cell. We have to ask the most dangerous question hiding inside the silence. Not, where is everybody? But something far closer to home. Are we perhaps the accident that was never supposed to happen? It's the question that turns the silence from a puzzle into something personal. Not where is everyone, but whether we were ever meant to be here at all. Because there is a possible answer to all that quiet, and it's unsettling precisely because it's so simple. Maybe the universe isn't hiding anyone. Maybe the reason no one calls back is that almost everywhere else no one is home. Maybe life that can look up and wonder is not the rule those staggering numbers promised, but a fluke so rare it may have happened in that entire ocean of suns, essentially once. And if that's true, then everything you are, every thought moving behind your eyes in this moment, is not ordinary at all. It may be the rarest thing in existence. This is the first real attempt to explain the silence, and it has a name. In the year 2000, two scientists at the University of Washington, the paleontologist Peter Ward and the astronomer Donald Brownlee, put it into a single book called Rare Earth. Their argument was careful, and it was chilling. They didn't claim the universe is dead, just the opposite. Simple life, microbes, single cells, the slime on a wet rock, may be scattered across the cosmos in staggering abundance. That part, they granted, might be common. But complex life, animals, nervous systems, creatures that move and hunt and eventually think, that, they argued, might be almost unimaginably rare. Here's the idea underneath it. Getting a planet to grow microbes may be relatively easy, but getting that same planet to hold still, safe and stable for the billions of years it takes to climb from a single cell all the way up to a mind, that may require a run of luck so specific it almost never happens twice. Think of it as a checklist, and every box must be ticked. Let's go through what a world actually needs. You need a stable star, not a violent one that flares and scorches, not one so small and cool its warmth is a whisper. A star that burns steadily for billions of years without a tantrum. You need an orbit inside the habitable zone, that narrow band around a star where water stays liquid. Too close and your oceans boil away. Too far and they freeze solid. Picture a single row of seats at exactly the right distance from a roaring bonfire. One row closer, you burn. One row back, you freeze. Earth sits in that one row. You need a rocky planet, sized just right. Big enough for its gravity to hold onto an atmosphere, but not so big it swells into a bloated ball of gas with no surface to stand on. You need oceans, most likely delivered by comets and asteroids, slamming into the young world during its violent childhood. You need plate tectonics, a cracked, restless crust of shifting plates that slowly buries and recycles carbon. Without it, the climate has no thermostat. Carbon builds up unchecked or drains away, and the whole world tips into runaway fire or endless ice. You need a large moon. Our moon quietly holds Earth's tilt steady, locked between about 22 and 24.5 degrees, which is why our seasons are gentle and predictable. Many scientists argue that without it, that tilt could lurch wildly over time, swinging the poles toward the sun and back, drowning the planet in chaotic, life-killing extremes. You need a magnetic field, generated by a churning core of molten iron deep inside the planet. That field is an invisible shield, an umbrella stretched over the entire world, deflecting the solar wind that would otherwise strip the atmosphere away, molecule by molecule, until the air is simply gone, and you need protection from above. Ward and Brownlee pointed to a giant planet like Jupiter, whose enormous gravity can catch or fling away comets that might otherwise rain down on the inner worlds. A massive older sibling taking the hit so you don't have to. Then, beyond all of that, you have to survive the neighborhood itself. You have to dodge nearby supernovae, dying stars that detonate with the fury of billions of suns, and you have to avoid gamma ray bursts, the single most violent explosions in the known universe, focused beams of radiation from collapsing stars that could strip a planet's protective ozone bare from thousands of light years away, a cosmic blowtorch capable of sterilizing a world it never even touches. Miss any one of these at the wrong moment, and the animals never come. And here is where it deepens. It isn't only about your planet or even your star. It may come down to where you sit in the entire galaxy. Astronomers call it the galactic habitable zone. Drift too close to the galactic center, and you're bathed in radiation, crowded by stars, caught in the crossfire of exploding suns going off around you. But wander too far out toward the lonely edge, and there simply aren't enough heavy elements, the iron, the silicon, the carbon forged inside earlier generations of stars, to build a rocky planet at all. Think of it like a city. The chaotic, violent downtown will kill you. The empty outskirts have nothing to build with. What you need is the quiet suburbs, and our sun sits comfortably in exactly that band, roughly 26,000 light-years out from the turbulent core. That distance is so vast that the light now reaching us from the heart of our galaxy began its journey around 26,000 years ago, back when our ancestors were living through the last great ice age, painting animals on the walls of caves. We didn't choose that address. We simply, quietly, got lucky. But there is one more thing on the list, and it may be the hardest to grasp because you can't see it. Time. Earth took roughly 4.5 billion years to produce a single technological species, and most of that time was spent going almost nowhere. Life appeared here astonishingly fast, within a few 100 million years of the planet cooling. But then it stalled. For nearly 3 billion years, for about 2/3 of Earth's entire existence, the crowning achievement of life on this planet was a single living cell. That's it. An ocean full of microscopic specks, dividing, drifting, and doing very little else, for a span of time longer than most stars will ever burn. Now, imagine you could stand on that ancient shoreline and simply watch. You would wait and wait, through ice ages and warm ages, through the slow drift of continents, and for a stretch of time you cannot even hold in your mind, the sea in front of you would stay essentially empty. No fish, no plants, no movement larger than a smear of green on the rocks. Life was here the entire time. It just wasn't going anywhere. And then, only around 600 million years ago, something shifted. Complex multicellular life finally took hold, and roughly 538 million years ago came the moment paleontologists call the Cambrian explosion. Place yourself in that ancient ocean. In a geological instant, a window of perhaps 13 to 25 million years, a handful of minutes on the clock of Earth's whole history, the seas erupt into animals. Eyes appear for the first time, shells, claws, jointed limbs, spines, Almost every basic animal body plan that has ever existed, including the distant blueprint of your own spine, was drafted in that single, sudden burst. Everything that came after, the fish, the forests, the dinosaurs, the mammals is a variation on what was written in those few extraordinary minutes. So here is the question that splits scientists to this day. Was any of that inevitable? Or was it a fluke? Human-level intelligence has appeared exactly once in 4 billion years, and only very recently. And that single data point is a trap, because we have no way to know whether it was destiny or dumb luck. Some researchers point to a striking clue. The eye, that impossibly complex instrument, did not evolve once. It evolved independently on separate branches of the tree of life, at least 40 different times. Octopuses and humans built almost the same camera-style eye, with no shared ancestor that had one. It's as if evolution keeps circling back to the same brilliant solution over and over whenever it's useful. And if nature reinvents the eye 40 times, they argue, then perhaps it reinvents intelligence too, wherever the conditions allow. Perhaps minds are not a fluke, but a destination. But others push back hard, and their counter is sobering. The eye may be common, but the entire lineage that produced technological intelligence happened only once, on a single narrow branch, in 4 billion years of trying. Tool-making, symbolic thought, the kind of mind that builds a radio telescope, that has never repeated, not once, and you cannot estimate how likely something is from a sample of exactly one. Both sides are looking at the same fossil record. Neither can prove the other wrong, and the silence overhead offers no help at all. In 1996, an economist named Robin Hanson took all of this and distilled it into one of the most quietly terrifying ideas in modern science. He called it the Great Filter. His reasoning was brutally simple. The path from lifeless chemistry to a civilization that spreads across the stars is not one leap, it's a sequence. Hansen laid out 9 hard steps in that chain: the right star and planet, the first self-copying molecule, the leap to complex cells, the rise of animals, of intelligence, of technology, and finally, expansion into the galaxy. 9 doors, and a civilization has to pass through every single one. Now hold that against the silence. If those steps were easy, the galaxy should be full, and it isn't, which means somewhere in that chain of 9 doors, at least one of them must be nearly impossible to open. One step where almost everything that starts down the path is stopped cold. That is the Great Filter, a wall, somewhere on the road to the stars, that almost nothing gets past. And this is where it becomes personal, because there are only 2 possibilities, and they could not be more different. The filter is either behind us, or it is ahead of us. Here is the reading that lets you breathe. Maybe the filter is already behind us. Maybe the near impossible step was the origin of life itself, that first living cell assembling out of dead chemistry. In 2025, a researcher at Imperial College London, Robert Endres, applied the mathematics of information theory to exactly that question, and argued that the spontaneous assembly of the first cell faces, staggering, almost prohibitive odds under the conditions of the early Earth. He was careful. He stressed this doesn't prove life's origin is impossible, only that our understanding may be dangerously incomplete. But if he's right, and if that first spark is the Great Wall, then something extraordinary follows. We already made it through. If the hardest step is behind us, then we are the survivors of a filter that stopped nearly everything else. Earth's quiet, crowded biosphere, every insect, every whale, every human being, becomes not a common thing at all, but the cosmos's single most precious and irreplaceable treasure. And if you followed all of this, the checklist, the 3 billion silent years, the 9 doors, then you understand why so many scientists find this reading almost beautiful. It would mean we are not late to the party. We are the ones who survive the door. That's the comfort. But there's a reason the silence still keeps some of the sharpest minds on Earth awake at night, because the filter has a second possible location, and it changes everything. What if the near impossible step is not behind us, but still ahead? Think about what that would mean. It would mean the origin of life was easy. It would mean complex creatures, intelligence, technology, all of it happens readily, all across the galaxy. It would mean the galaxy has been filling again and again with civilizations exactly like ours, reaching exactly the stage we've reached, and then something stops them, reliably, completely, before a single one of them ever fills the sky. If that is true, then the silence is no longer a comfort. The silence becomes a warning, written in the empty space where 1,000 older civilizations should be. It would mean we are not looking at a graveyard of worlds that never woke up. We would be looking at a graveyard of worlds that woke up, rose, reached for the stars, and died anyway. And that raises the most dangerous question a species like ours can ask. If something out there reliably ends civilizations right around the moment they become capable of being heard, then what exactly is coming for us? Is the thing that silences the galaxy a threat that finds them from the outside, or is it something far more intimate, something every intelligent species eventually builds or becomes or unleashes upon itself? The dark may not be empty because no one was ever born. It may be empty because no one survives what comes next. So let's follow both of those possibilities into the dark, because they lead to the two most frightening answers anyone has ever proposed for the silence. The first says the danger comes from outside, that the quiet sky is not empty at all, but camouflage, that the reason the galaxy sounds dead is that everyone still alive has learned the hard way to make no sound whatsoever. The second answer is worse, because it says the threat isn't out there among the stars, it's in here, in us, in the very thing that let us build a radio telescope in the first place. 2 doors, both open onto something dark. We'll take the first one first. There's an idea that reframes the entire silence, and it comes not from an observatory, but from a novelist. In 2008, the Chinese science fiction writer Liu Cixin gave it a name that has haunted the field ever since: the dark forest. Picture the universe not as an empty sky, but as a vast forest on a moonless night. And every civilization inside it is a hunter, armed, moving without a sound. In this forest, you cannot see who else is out there. You cannot know their intentions. You can only know one thing for certain, that they, like you, are afraid. Here's the logic underneath it, and it's colder than it first appears. Imagine you hear something move in the dark, another hunter. You have no way to tell if they're friendly or hostile. Worse, even if you could somehow know they're peaceful right now, you can't know what they'll become in 1,000 years, when their technology may have exploded past yours, and they're thinking exactly the same thing about you. That trap has a name: the chain of suspicion. I can't be sure you're safe. You can't be sure I am. And neither of us can afford to be wrong, because in this forest, a single mistake is fatal. So what is the rational move? Silence. You stay hidden. You reveal nothing. And if you ever do detect someone who has revealed themselves, someone careless enough to call out, the safest thing you can possibly do is eliminate them before they become a threat. Not out of cruelty, out of fear. Under this brutal logic, the civilizations that survive are the ones that learn to stay quiet. The ones that called out into the dark were simply, permanently, silenced. In this forest, the one lit window is not a comfort, it's a target. But let's be honest about what this is. The dark forest is a hypothesis, not a proven law of the cosmos, and its critics are sharp. The whole model rests on a stack of assumptions that may not hold. It assumes that alien minds are relentlessly hostile, or at least relentlessly afraid. It assumes that a first strike across light years is cheap and easy, that you can reliably destroy a distant world before it ever sees you coming. and it assumes a level of certainty about strangers that, some argue, no civilization could ever actually have. Remove any one of those assumptions, and the dark forest starts to fill with light again. We simply don't know which assumptions are true, and that uncertainty should make what we've actually done as a species feel deeply strange, because for the last 100 years, humanity has done the precise opposite of hiding. We have been shouting into the dark, deliberately. In 1974, from the Great Dish at Arecibo in Puerto Rico, we beamed a message straight at a dense knot of stars called Messier 13, a globular cluster of several 100,000 suns. The message was tiny, 1,679 ones and zeros, arranged to sketch out who we are, our numbers, our DNA, our little solar system. But that cluster is so far away that the signal won't arrive for roughly 25,000 years. Sit with that. When our message finally reaches those stars, we will be as ancient and distant to any listener there as the last Ice Age painters, the ones drawing bison on cave walls, are to us right now. And that was only the beginning. Bolted to the Pioneer, 10 and 11 probes are metal plaques, engraved star maps, marking the location of Earth for anyone who might one day find them drifting. On the 2 Voyager spacecraft, we went further still. Each carries a golden record, greetings in 55 languages, 115 images, the sound of rain, of a heartbeat, of a mother speaking to her child, an entire portrait of our world, pressed into gold, addressed to no one and everyone. For a moment, imagine you could follow one of them out there right now. Voyager 1, the most distant object human hands have ever made, is drifting through the black nearly 1 full light day from home, about 16 billion miles, or 26 billion kilometers away. It's so far that a radio whisper from Earth moving at the speed of light now takes more than 23 hours just to catch up to it. Out there, the sun is only the brightest star in a sea of them. The cold is a fraction above absolute zero, and that golden record hangs on its flank, gleaming, silent, still carrying our address into the deep. We didn't stop with the 20th century. In 2017, a group called METI aimed a radar antenna in Norway at Luyten's star, a red dwarf just 12.5 light years away, close enough that a reply, if one ever came, could reach us around the year 2043. And in 2008, NASA did something almost tender and almost reckless. It beamed a Beatles song across the universe toward Polaris, the North Star, roughly 430 light years off. That song is still traveling. It will still be traveling long after everyone who wrote it and everyone who sent it is dust. And this is where the two ideas collide head-on, because the greatest scientific mind of a generation looked at all this shouting and was alarmed. Stephen Hawking warned more than once that broadcasting our existence to the cosmos could be a catastrophic mistake, that if anyone is listening, we may deeply regret making ourselves easy to find. Others in the field put it more bluntly. It's like standing up and shouting in a forest before you have any idea whether it's full of predators. But the broadcasters have an answer, and it's a good one. You might reasonably think that after a century of leaking television and radio, we've already given ourselves away. So why stay quiet now? That's exactly their argument. Hiding, they say, is already futile. Our planet has been broadcasting the chemical signature of life for some 2.5 billion years. The oxygen in our air, a fingerprint that no lifeless world produces visible to any sufficiently advanced telescope. We cannot unring that bell. We never could. And here is the part that should stop you cold. Every one of those deliberate messages, every plaque, every golden record, every beam of music sent toward the stars, was decided by a small handful of people, a few scientists, a few institutions. No treaty, no vote, no consent from the 8 billion of us whose location they were revealing. If the dark forest is real, then a tiny group of humans may have made the most consequential decision in our species' history on behalf of everyone without ever asking. But now, let's open that second door, because there's a version of the filter that needs no hostile aliens at all, no hunters, no dark forest. In this version, the thing that silences the galaxy is far more intimate and far harder to escape. The idea is simple, and it's chilling. Intelligence may be self-terminating. The same spark that lets a species build telescopes and rockets may, almost inevitably, also let it destroy itself, because intelligence hands out power far faster than it hands out the wisdom to wield it. Think about our own last 80 years, and watch how fast the dangers multiply. We built nuclear weapons, enough at the peak to throw so much soot into the sky that the sun itself would dim, crops would fail worldwide, and a nuclear winter could starve the survivors of the blast. Then we learned to edit the code of life itself with tools like CRISPR, and with that same power, a lab could engineer a plague deadlier than anything nature ever made. Then we began building artificial minds that may one day outthink us, and a powerful enough intelligence aimed at the wrong goal might pursue it with no particular concern for whether we survive. We've imagined machines that build copies of themselves, replicating without limit until they consume everything, the runaway scenario some call grey goo, and all the while we've been quietly warming our own world, where a thawing Arctic could release vast stores of methane, and the warming could begin to feed itself, sliding beyond anything we can stop. Nuclear fire, engineered plague, runaway machines, a poisoned sky, every one of them born from the same mind that reached for the stars. Researchers who study these dangers often mark a single moment as the true beginning of the peril. July 16th, 1945. In one blinding flash over the New Mexico desert, the first nuclear device detonated, and in that instant, we became the first species on this planet ever known to hold the power to end itself. We have lived every single day since inside that new and fragile reality, less than a single human lifetime. And now we arrive at the most unsettling idea in all of this, one that quietly poisons any comfort you might have been reaching for. We look back across our history, through every close call, every crisis that didn't quite become the end, and we tell ourselves a reassuring story. We survived. We must be doing something right. We must be wise. But there's a devastating flaw in that reasoning. Scientists, including Nick Bostrom and his colleagues, call it the anthropic shadow, and it works like this. We can only ever find ourselves in a history where we survived. The versions of Earth where the missiles flew, where the plague escaped, where the machine turned, those versions have no one left in them to look back and wonder. We cannot see our own near misses that went the other way, because in those timelines, there is no us. Every catastrophe that would have erased us is invisible to us, by definition. So the survival we're so proud of may not be evidence of wisdom at all. It may just be evidence that we're the ones who got lucky, and that's the trap. We look at our unbroken streak and call it skill, but a species that survived by pure chance would see exactly the same streak, right up until the moment it ended. We may be imitating luck, not wisdom, and luck, given enough time, always runs out. So step back and look at what these two dark answers have in common. Whether the filter is out there, a forest full of silent hunters, or in here, coded into the nature of intelligence itself, they point to the same terrible conclusion. The most dangerous moment in a civilization's entire existence may be this exact one. Young, newly powerful, loud, reaching for the stars before it has learned how to survive itself. If you followed this far, you can feel the weight of where it leaves us. We are a species that gained world-ending power in 1945 and started broadcasting its location to the cosmos at almost the same time, with no way of knowing whether either choice was a fatal one. That's not a comfortable place to stand. And these are still hypotheses, remember. The critics have real points and the silence hasn't confirmed any of them, but the questions they raise will not go away. And yet, there's a possibility we've raced right past, a gentler one. Because maybe the silence isn't menace at all. Maybe no one is hiding, and no one is dying. Maybe the civilizations really are out there, thriving, curious, reaching outward just like us. And the reason we've never heard a single one of them has nothing to do with fear, or war, or self-destruction. Maybe it's something far simpler, and in its own way, far more heartbreaking. Maybe the universe is just too big. Maybe the distances between the stars are so vast, so brutally physically impossible to cross, that every civilization is sealed inside its own tiny pocket of space, able to see the others perhaps, but never, ever to reach them. A prison with no walls and no escape. Not because anyone built it, but because that is simply how reality is made. And if that's true, then the silence isn't a threat. It's a life sentence. A life sentence? That's the third possibility. And unlike the others, it needs no villain. No war, no act of self-destruction. It asks us to imagine something almost stranger. Imagine the galaxy as full of life, full of thriving, peaceful, curious civilizations, each one gazing up at the same silent sky we are, wondering the very same thing. And every single one of them is trapped, not by fear, not by hostility, but by the one thing no amount of intelligence can ever argue its way past, the sheer, crushing size of the space between the stars. Because here's what almost no one truly feels about that distance. It isn't just big, it may be uncrossable. Let's look at the closest gap of all, the shortest possible interstellar journey a human being could ever attempt. Our nearest neighboring star system is called Alpha Centauri. In cosmic terms, it's practically next door, and it sits 4 1/3 light years away, about 25 trillion miles, or 41 trillion kilometers. That number is already past the point where your mind can hold it, so let's make it real. The fastest spacecraft NASA has ever launched toward deep space is New Horizons, the probe that flew past Pluto. It's screaming through space at more than 36,000 miles an hour, fast enough to cross the entire United States in about 7 minutes. And if you pointed New Horizons at Alpha Centauri and let it fly, it would take roughly 78,000 years to arrive. Sit with that for a moment. 78,000 years ago, our ancestors were still in the Stone Age. Neanderthals still walk the earth. The great human migration out of Africa had barely begun. If those distant people had somehow launched our fastest probe at the dawn of our species, it would still be out there in the dark right now, still not arrived. And that is the nearest star. That's the easy one. Most of the stars where we might actually hope to find a civilization sit hundreds or thousands of light years beyond even that. The speed of light isn't just a speed limit. It's a wall built into the foundations of reality. The absolute fastest anything can travel, and nothing with mass can ever reach it. And that wall does something to the universe that's genuinely difficult to accept. It means everything you see is the past. Look at the sun, carefully, never directly, and you're not seeing it as it is. You're seeing light that left it about 8 minutes ago. If the sun vanished this instant, you'd feel nothing, notice nothing, for 8 full minutes. Now stretch that out. When you look at a star 1,000 light years away, you are seeing light that began its journey 1,000 years ago, around the time the first stone castles were rising in medieval Europe. You aren't seeing that star now, you're seeing a ghost. So, imagine we detect a signal from a civilization 1,000 light years away. We would be receiving a message 1,000 years old. We would be listening to a voice from a world as it existed 10 centuries ago. And if we answered, if we sent our reply straight back at the speed of light, it would take another 1,000 years to arrive. 2,000 years for a single exchange. The people who sent the message would be 20 generations in their graves before our hello ever reached their planet. Every conversation across the stars is one way, delayed, and haunted by time. But the distance creates an even crueler problem, one of timing. For two civilizations to ever detect each other, they don't just have to exist. They have to exist and be broadcasting at the same cosmic moment. Their brief windows of technology overlapping across billions of years of history, and our window is heartbreakingly thin. We have been sending signals into space for roughly 1 century. Set that against the age of the cosmos, nearly 14 billion years, and our entire broadcasting history amounts to about 0.000000007% of the time the universe has existed. Here's what that fraction feels like. If you compressed all of cosmic history into a single year, then everything humanity has ever transmitted, every radio show, every television signal, every deliberate message to the stars, would occupy about 1/5 of 1 second, a single blink in a year-long film. Now picture 2 of those blinks going off somewhere in a galaxy 100,000 light-years wide. For us to catch them, they'd have to flash at nearly the same instant and be close enough to reach each other. The odds of 2 such flickers ever aligning in both time and space shrink toward nothing. 2 ships passing in an endless night, each carrying a lantern, each looking the other way. Maybe you're thinking what many people think at this point. Fine, signals are slow, so why not just go? Build a faster ship, cross the gap in person. But the problem was never really engineering. It's physics, and it's arithmetic, and it's brutal, because interstellar space, which looks so perfectly empty, is not empty at all. Let's follow the danger as it stacks up. Imagine you could stand aboard a ship traveling at even 1/10 of the speed of light, a spacecraft moving fast enough to reach the nearest star within a human lifetime. From your seat, that thin scattering of matter drifting between the stars is no longer harmless. A single microscopic grain of dust, a mote you couldn't even see, would slam into your hull with the energy of a hand grenade, and a slightly larger grain with the force of a bomb. It gets worse. The wispy interstellar hydrogen, just a few lonely atoms per cubic centimetre, thinner than the best vacuum we can make in a laboratory, would transform in your frame of reference into a relentless stream of searing radiation, a wind of atomic bullets scouring the front of your ship every second of the journey. So you add shielding, thick armour to survive the dust and the radiation, but every kilogram of shielding is more mass, and more mass demands exponentially more energy to push up to speed. So the ship grows heavier, and the heavier it grows, the more fuel it needs. And the more fuel it needs, the heavier it grows again. Watch the numbers climb. Just to accelerate a modest craft to 1/10 of light speed, accounting for how staggeringly inefficient any real engine would be, you'd need something on the order of an entire nation's yearly energy output. And then, at the far end, you'd have to spend all of that energy a second time just to slow down and stop. One NASA study of a laser-driven sail concluded it would take more power than all of human civilization currently generates, many times over, simply to push the craft on its way. Speed up, slow down, twice the impossible, and you still haven't left. Here's the honest truth about where we stand. Every propulsion system that could actually cross those distances in a reasonable time, fusion drives, antimatter engines, laser-push sails, exists only on paper. Not one has ever been built. The most serious real effort, a project called Breakthrough Starshot, backed by the physicist Stephen Hawking before his death, doesn't even dream of sending people. It hopes only to fling a fleet of tiny gram-scale chips, each smaller than a postage stamp, toward Alpha Centauri, and even that pushes the very edge of what's possible. So if we can't send a fast ship, maybe we send a slow one. A generation ship, an enormous ark, a self-contained world where people are born, live out their entire lives, and die, so that their distant descendants might one day arrive at a star none of them will ever see. But think about what that actually requires. A sealed, artificial ecosystem, recycling every breath of air, every drop of water, every scrap of food, functioning flawlessly without resupply for centuries, longer than most nations on Earth have even existed. And a single failure, one broken system, one crop collapse, one war between decks, one generation that simply loses the will to continue, and the ark doesn't reach another star. It becomes a tomb, drifting silently through the dark, carrying the bones of everyone who ever believed it would make it. And now the distance reveals its final, quietest cruelty. Even if a civilization solved all of it, the energy, the shielding, the centuries, there may be no reason to ever try. Think about why humans have always explored. We crossed oceans for trade, for gold, for spices, for resources we could bring home. But an interstellar colony can send nothing back. It's 25 trillion miles away, at the very nearest. There is no shipping route, no trade, no resupply, no return. A colony 4 light years off couldn't send you a resource or a profit or even a reply in anything less than a decade, and realistically, in centuries. Which means interstellar expansion isn't like exploring the new world at all. It's pure, one-way sacrifice, pouring the wealth of an entire civilization into a ship that vanishes forever, for a reward that no one who paid for it will ever see. And a civilization that does that math might make a very reasonable choice. It might settle a few of its nearest neighbors, plant a handful of flags in the dark, and then simply stop. Content, home, silent. If this is the answer, then the galaxy isn't a graveyard and it isn't a battlefield. It's just a scattering of islands, each one too far from the others to ever build a bridge. Every civilization sealed inside its own small pocket of space, glimpsing the distant lights of the others across a canyon that can never be crossed. But there's a flaw in that comfort, a single idea that threatens to unravel the entire tyranny of distance. And it comes from one of the most brilliant minds of the 20th century, the mathematician John von Neumann. He realized something simple and staggering. To cross the galaxy, you don't need to send a living crew at all. You don't need to solve the trade problem, or the lifespan problem, or the sacrifice problem. You only need to build one machine, a self-replicating probe, a robot that travels to the nearest star, mines the raw materials it finds there, from asteroids, from moons, and uses them to build 2 exact copies of itself. Then those 2 fly on, and each builds 2 more, then 4, then 8, then 16. And this changes everything, because that's exponential growth, the same runaway doubling that lets a single dividing cell become a living body, even crawling along at a fraction of light speed, with each probe patiently building the next. A single civilization launching one such machine could blanket the entire 100,000 light-year galaxy, every star, every system, in just a few million years. And a few million years is nothing. Against the galaxy's 13.5 billion year lifetime, a few million years is about a week in the span of a human life. So here is the collision that this entire idea has been building toward. The galaxy has existed for over 13 billion years. If even one civilization anywhere, at any point in all that vast history, ever built even one of these self-replicating probes, then the machines should have finished filling the galaxy hundreds of millions of years ago. They should be in our solar system right now, mining our asteroid belt, orbiting our sun, already here, waiting long before humans ever existed. They are not here. We look, and we find nothing. That absence is so glaring that in 1981, the physicist Frank Tipler used it to make a blunt and chilling claim. Since the probes would already be here if anyone had built them, and they aren't, then no one is out there. We are alone. But others refuse to accept that. Carl Sagan pushed back, and researchers like Robert Freitas argued that both sides had made shaky assumptions, that maybe truly self-replicating probes are far harder to build than they look, or that modest, quiet machines could be drifting through our solar system right now, unnoticed, and we simply wouldn't recognize them if we saw them. And that disagreement is still unresolved. No one has settled it. But notice what it does to the tyranny of distance. Distance is a genuinely powerful answer to the silence, maybe the most honest one, because it needs no monsters and no catastrophes, only physics being exactly what it is. If you followed the energy, the timing, the sacrifice, you can feel how real that wall is. And yet, distance alone can't be the whole story, because the one thing that should defeat distance, the self-replicating probe, is the very thing that's missing. The workaround exists. The galaxy had all the time it needed, and still silence, which forces us back to that unsettling loose thread Sagan left dangling. This entire time we've been assuming that if they were out there, if their probes had reached us, if their signals were washing over our planet, we would know, we would recognize it. But what if that assumption is simply wrong? What if the evidence isn't missing at all? What if the probes, the signals, the signs of other minds are already here, already around us, maybe already inside our own solar system, and the reason we've never noticed is not that the universe is empty, or hostile, or too vast to cross? What if the reason is us? What if we've been staring straight at the answer for a very long time, and calling it nature? Calling it nature, that's the possibility we now have to sit with, and it may be the most disorienting one of all, because every answer we've explored so far has quietly agreed on a single point, that the silence is real, that the sky is genuinely empty of voices. But what if it isn't? What if the forest is not deserted at all, but crowded and full of sound, and the reason we hear nothing has nothing to do with anyone being absent? What if the voices are there, all around us, and we simply cannot perceive them? What if we are not alone in the dark? What if we are only blind in it? There's a name for the gentlest version of this idea, and it comes from a radio astronomer at MIT named John Ball. In 1973, in a short scientific paper, he proposed something that has unsettled people ever since. He called it the zoo hypothesis. The idea is simple and strangely humbling. Imagine that advanced civilizations do exist, many of them older and wiser than us, and that they know we're here. They've known for a long time, but they've made a deliberate choice to leave us completely alone. Think of how we treat a wildlife preserve. Biologists study the animals inside it with enormous care. They watch, they record, they learn, but the entire point is to not interfere, to let the ecosystem unfold on its own, untouched, natural. Under the zoo hypothesis, that's exactly what we are. Not a colony, not a target, an exhibit, a protected wilderness, quietly observed from just beyond the fence by watchers who have decided that the most respectful thing they can do is nothing at all. Notice how different this is from a galaxy full of frightened hunters. This isn't fear, it's restraint. Maybe they're waiting for us to reach some milestone, some level of maturity, before they ever say hello. And there's a darker version. What if the quarantine isn't for our protection, but for everyone else's? What if we've been sealed off, walled away, because something about us is best kept contained? But the zoo hypothesis has a weakness, and the moment you see it, it's hard to unsee. For this to work, it can't be one civilization observing us. It has to be all of them. Every advanced species in the entire galaxy, across millions of years, would have to independently agree to the very same policy of total silence, and then hold to it perfectly, without a single exception, for the whole of human history. And that's an almost impossible thing to ask, because it only takes one civilization that disagrees, one that decides to break the silence and call out, one that simply ignores the rule and starts colonizing. A single defector, anywhere, at any point in all those ages, and the fence collapses. The whole zoo comes apart. Keeping 8 billion of us convinced we're alone would require a conspiracy of cosmic proportions, unbroken across the entire galaxy, forever. And conspiracies that large, that perfect, tend not to hold. So maybe the zoo isn't the answer, but it points us toward a deeper, stranger possibility, one that doesn't require anyone to agree on anything at all. What if we hear nothing because we've been listening for the wrong thing? Here's something worth sitting with for a moment. Right now, as you're taking in these words, the space around you is completely saturated with invisible signals, radio broadcasts, television, the Wi-Fi moving through your walls. Countless waves are passing through the room this very instant, through the furniture, through the air, straight through your own body, and you feel absolutely nothing. You have no sense that can detect them. To your body, they may as well not exist. Now understand this. For almost the entire history of our species, we were exactly that blind to radio itself. Radio waves were completely unknown to humanity until barely a century and a half ago. The physicist James Clerk Maxwell predicted them on paper in the 1860s, and Heinrich Hertz first produced and detected them in his laboratory in the 1880s. Before that, for tens of thousands of years, those waves were streaming through every human who ever lived, through the builders of the pyramids, through every army, every empire, every child who ever looked up at the stars, and not one of them had the faintest idea. We were deaf to an entire layer of reality, standing right inside it. So think about what that means for the search. We've spent 60 years listening for aliens using radio, because radio is what we invented. But radio might be nothing more than a passing phase, a technology a civilization uses for a brief window and then abandons, the way we abandon smoke signals, the way we're already trading copper wires for pulses of light and glass. And there are so many other ways to speak. A civilization could send messages with tight beams of laser light, or with neutrinos, ghostly particles so faint they pass straight through the entire Earth without stopping. And that's not fantasy. In 2012, physicists at Fermilab actually did it. They encoded a word and transmitted it using a beam of neutrinos straight through more than 200 meters of solid rock, about 800 feet of pure stone, and read it cleanly on the other side. We have already sent a message through the body of the Earth itself. Now imagine a civilization 1 million years ahead of us, using physics we haven't even discovered yet. And here's the cruelest part of the timing. If some distant civilization used radio for only a few centuries before moving on to something better, and if their radio era ended 100,000 years ago, then their signals rolled past our world long before we had any instrument to catch them. We didn't miss them because they were quiet. We missed them because we arrived at the party after everyone had already gone home. But maybe the strangest possibility isn't about how they speak. It's about what they've become. We tend to assume that intelligence, once it appears, keeps reaching outward, building bigger rockets, spreading to more worlds, growing louder and more visible over time. But what if that assumption is completely backwards? What if intelligence, past a certain point, turns inward instead? Look at our own trajectory, honestly. We are already beginning to merge with our machines. Brain-computer interfaces, real devices being implanted in real people right now, are starting to wire human thought directly to silicon, and scientists seriously discuss where that road might lead. Mind uploading. The idea of copying a consciousness out of its fragile, dying biology and into a durable digital form, escaping the body entirely, a kind of digital immortality. Now follow that path outward, or rather, inward. A researcher named John Smart proposed something he calls the transcension hypothesis. His argument is that every sufficiently advanced civilization, sooner or later, stops expanding into outer space, because the real frontier isn't out there at all. It's in here, in inner space, in computation so dense, so fast, so miniaturized and efficient that an entire civilization could fold itself down into a space smaller than a planet, living out billions of subjective years in worlds of pure thought. And a civilization like that would barely disturb the visible cosmos at all. No giant fleets, no galaxy-spanning empires, no signals blasting across the light years. Just a quiet, dense point of unimaginable activity turned entirely inward, indifferent to the empty sky outside. Think about what that would mean. Post-biological minds, the descendants of 1,000 civilizations, might be scattered all around us right now, in forms we would never recognize as alive. Not hiding, not hostile, simply elsewhere, absorbed in something we can't even imagine, waiting, perhaps, for us to grow up enough to notice. And now we reach the assumption buried under the entire search, the one we almost never question. We assume that aliens would want to talk to us at all. We picture them as curious, social, reaching out the way we reach out, lonely for company in a vast universe. But that is a deeply human portrait, and there's no guarantee the universe agrees with it. Intelligence might just as easily arise in a creature that is fundamentally solitary, a mind with no instinct to connect, no drive to broadcast, no interest in whether anyone else is out there. Or it might arise in a species so deeply xenophobic that it treats every possible outsider as a lethal threat and would sooner stay silent than risk being found. Or, and this may be the most unsettling of all, it might think in a way so alien to us that even if it were shouting directly at us, right now we could not recognize it as a message. Its thoughts, its signals, its entire way of being could wash over us as nothing but meaningless noise. Static, the way birdsong is just background to someone who has never imagined it might be language. And here's the honest, frustrating truth about this whole idea. We cannot test it, we can only entertain it. There's no experiment to prove that alien minds are unreadable, because if they were, we'd have no way to tell the difference between a message we can't decode and no message at all. So step back and see what has quietly happened here. Watch how every pillar of the search begins to crack at once. We assumed they'd use radio. They might not. We assumed they'd expand outward. They might turn inward. We assumed they'd be social. They might be silent by nature. We assumed, beneath all of it, that they would be enough like us to find, and they might be nothing like us at all. 4 assumptions, every one of them possibly wrong. And if they're all wrong together, then the most disturbing picture of all comes into focus. The galaxy could be crowded, genuinely teeming with minds, ancient and strange and everywhere, and we would still hear nothing. Not because the forest is empty, but because we were born with the wrong senses, listening on the wrong channel, expecting the wrong kind of neighbor at the wrong moment in time. The lights of the other windows could be blazing all around us and simply shining in a color our eyes were never built to see. If you've followed all of that, then you've arrived at one of the most important ideas in this entire mystery, and it's a genuinely liberating one. We have been treating the silence as proof that the universe is empty. But silence is not proof of emptiness. It never was. Scientists have a careful phrase for this. Absence of evidence is not evidence of absence. The fact that we have found nothing and the claim that there is nothing are not the same statement. They were never the same statement. And once you truly feel that difference, the whole silence changes character. It stops being a verdict. It becomes a question about us. About the narrowness of our senses, the youth of our science, the limits of a single human mind trying to imagine minds it has never met. We may not be alone, we may simply be blind, standing in a cosmos that is already, quietly, speaking. But there's a reason scientists don't stop there, a reason they refuse to just fold their arms and accept that the aliens are unknowable. Because if our old assumptions are wrong, the answer isn't to give up the search, it's to search differently, to stop straining for a friendly hello, and start hunting instead for the things a civilization would leave behind, whether it wanted to or not. The waste heat of vast machines, the strange artificial dimming of a star, chemistry in an atmosphere that nature alone could never produce, fingerprints too large and too physical to hide. Because here is what changes everything. We have already built the telescopes to look for exactly those fingerprints. The hunt is underway right now, tonight, across millions of stars. And a few times, just a few, we've pointed those instruments at the sky and found something we still cannot explain. That's where the search stands today, and it marks a complete change in strategy. For 60 years we mostly listened, hoping to catch a friendly hello. But if the last few chapters taught us anything, it's that a hello may never come, because they can't reach us, or won't, or simply don't think the way we do. So scientists changed the question. They stopped waiting to be contacted, and they started hunting instead for something a civilization cannot hide, no matter how advanced, no matter how indifferent, the physical fingerprints of its technology, the heat, the light, the impossible chemistry. Astronomers call these technosignatures, and the hunt for them is the most sophisticated search humanity has ever mounted for company in the cosmos. It's happening right now, tonight, across the sky, and more than once it has made our instruments flicker with something strange. But to hunt for a civilization, you first have to ask what a civilization even looks like from light years away, and the answer, it turns out, comes down to a single thing: energy. In 1964, a Soviet astronomer named Nikolai Kardashev proposed a way to rank any civilization in the universe, not by its art or its politics or its biology, but purely by how much power it can command. He laid out 3 rungs on a ladder. A Type 1 civilization has mastered all the energy available on its home planet, every ray of sunlight that strikes it, every wind, every wave, every drop of geothermal heat. A Type 2 has gone further and learned to capture the entire energy output of its star, not a fraction of it, but all of it. And a Type 3 commands the energy of an entire galaxy, hundreds of billions of stars, harnessed. Now, here's where it becomes humbling. Where do we sit on that ladder? Carl Sagan worked out the answer, and it stings a little. We are not a Type 1 civilization. We're not even there yet. On his scale, present-day humanity sits at roughly Type 0.73. We haven't even learned to fully harness our own planet. And by one estimate from researchers at NASA's Jet Propulsion Laboratory, at our current rate, we won't reach Type 1 until around the year 2371, roughly 350 years from now. But sit with what that ladder implies. A civilization even one rung above us, a Type 2, wrapping its whole star, would be pouring out energy on a scale so vast that it could not possibly stay hidden. Because energy, once used, doesn't vanish. It has to go somewhere. And that single, unbreakable law of physics is exactly what the hunt is built on. Follow that logic, and you arrive at one of the boldest ideas in all of science. Back in 1960, the physicist Freeman Dyson asked a simple question. If a civilization keeps growing and keeps needing more power, eventually its own planet isn't enough. So what would it do? It would go to the source. It would build a colossal swarm of structures of vast panels by the millions, surrounding its entire star, drinking in nearly all of its light. We call it a Dyson sphere. And here's the beautiful part, the part that makes it findable. Any machine that absorbs that much energy must, by the laws of physics, release waste heat, the same way the back of your refrigerator is warm, the same way an engine glows. A Dyson swarm would soak up a star's visible light and re-radiate it as infrared heat. So from a distance, the star would look wrong. It would appear strangely, impossibly warm in the infrared, as if something were wrapped around it. And astronomers have gone looking for exactly that. In 2024, a project called Hephaestus combed through the data of roughly 5 million stars, hunting for that telltale infrared glow. And they found 7 candidates, 7 stars giving off more heat than they should, with no easy explanation. 7 possible alien megastructures. But before your heart races too fast, and this is the discipline that defines this entire field, the scientists themselves urged caution. That same excess infrared heat can be produced by perfectly natural things. A disk of warm dust, a distant galaxy blurred into the background, and later analysis suggested some of these candidates may be exactly that. Not machines, just dust and distance and coincidence. And then there's the strangest star of all. In 2015, astronomers noticed something bizarre about a star now nicknamed Tabby's star, about 1,500 light-years away. Stars are supposed to be steady. When a planet passes in front of one, it dims by a tiny, predictable amount on a clean schedule. But Tabby's star did nothing of the sort. It dimmed dramatically, once by a staggering 22%, at random, unpredictable intervals, in patterns that broke every rule astronomers knew. Nothing natural seemed to fit. No planet could block that much light. And so, inevitably, one hypothesis went viral. Perhaps we were watching an alien megastructure, a half-built Dyson swarm, passing in front of the star, blocking its light in enormous, irregular chunks. For a while, it was electrifying, but then astronomers looked closer at the color of the dimming, and they found something telling. The star's light was being blocked more at some wavelengths than others. A solid structure would block all colors equally. A wall is a wall, but dust doesn't. Fine dust filters light unevenly, exactly the way Tabby's star was doing. The leading explanation now isn't a megastructure at all. It's a vast, uneven cloud of dust, most likely the debris of shattered comets, drifting around the star. Once again, the exotic answer dissolved into the natural one. The hunt doesn't stop at heat, though. It reaches for signals, too. Radio astronomers scan the sky for narrow-band transmissions, signals compressed into a single razor-thin sliver of frequency, the kind of pure artificial tone that nature almost never produces on its own. They concentrate especially on a quiet band of the radio spectrum near the natural frequency of hydrogen, a region SETI pioneers nicknamed the water hole, a calm, sensible place where two civilizations might think to meet. Others hunt invisible light instead, watching for nanosecond flashes, laser pulses so brief and so bright they could only be deliberate. These are patient, grinding searches, sweeping across one star system after another, year after year, quietly recording millions upon millions of signals, and then discarding almost every one of them as the echo of our own noisy world. And there's a newer front in the search, perhaps the most promising of all. The James Webb Space Telescope can now do something astonishing. It can read the atmospheres of distant worlds. As a planet crosses in front of its star, a sliver of starlight filters through its air, and the gases there leave their chemical fingerprints in that light. Webb can catch them. This is where things got genuinely exciting. A planet called K218b, about 124 light-years away, drew intense attention when a team using Webb reported signs of a molecule called dimethyl sulfide in its atmosphere. And that molecule matters, because here on Earth it's produced almost entirely by living things, by marine plankton in the oceans. A possible whiff of life on another world. For a few electric days, it felt like it might be the discovery of the century, the first faint breath of a living alien biosphere, drifting across 124 light-years of empty space to reach us. But here comes the pattern again, the same rigorous, deflating caution. Other independent teams took the very same data and reanalyzed it, and they found that the signal was far shakier than it first appeared, that the faint fingerprint could just as easily be random noise in the instrument or other lifeless molecules. Worse, that same life molecule has since been detected drifting in comets and in the cold clouds between stars. places where nothing lives at all. The claim, for now, remains unproven. A tantalizing maybe, not a yes. And then, sometimes, the mystery doesn't come from a distant star. It comes right into our own solar system. In 2017, astronomers spotted something that had never been seen before, an object tumbling through our neighborhood that had come from another star. We named it Oumuamua, and it was deeply strange. It was oddly elongated, and as it swung past the sun and began to leave, it sped up. It showed a gentle push, an acceleration that gravity alone couldn't explain. Comets do that too, but only because they vent gas and dust as they heat up, which shoves them along like a jet. Oumuamua showed no visible tail, no coma, no obvious jets. It simply accelerated, quietly, for no reason we could see. The debate was fierce. One Harvard astronomer argued we should at least consider the possibility that Oumuamua was artificial, a thin, light-catching sail pushed by the pressure of sunlight itself. Others proposed stranger but natural answers, that it was made of exotic hydrogen or nitrogen ice, quietly evaporating in a way too faint for us to see, or that it was an impossibly fluffy, porous shard of frozen debris. No radio signal ever came from it. The argument was never fully settled, but it put the whole world on notice, because 2 years later, in 2019, a second interstellar visitor arrived. And this one, called Borisov, was almost disappointingly ordinary. A textbook comet with a bright, normal tail. No mystery at all. And then, on the 1st of July, 2025, a third one appeared. Its name is 3I Atlas, the third interstellar object ever discovered, caught by a survey telescope in Chile as it swept in from the dark on a path that could only have come from beyond our solar system. And this time, we were ready. This time, we didn't just watch. We aimed our most powerful ears directly at it. Picture the scene. In December of 2025, as the visitor made its closest pass by Earth, still a safe 167 million miles away, about 270 million kilometers, a team from the Breakthrough Listen project swung the giant Green Bank telescope toward it. This is the largest steerable dish on the planet, 100 meters across, more than 300 feet of precision metal, sensitive enough to detect a transmitter weaker than a mobile phone from that impossible distance. For hours, they listened across a wide range of frequencies, hunting for the one thing that would change history, a narrowband signal, the unmistakable whisper of technology. The instrument caught over 400,000 candidate signals. Imagine the tension as they filtered them, one by one. 400,000 narrowed to a few thousand to just 9. 9 signals worth a closer look. 9 chances that this cold visitor from another star was trying to speak. And then, one by one, all 9 fell away. Every single one turned out to be interference, radio noise from our own machines, from our own restless planet. Not a single signal came from the comet, because that's what 3I Atlas turned out to be. A comet. It grew a coma. It sprouted a tail. It vented gas and dust exactly as a ball of ancient ice should when the sun warms it. It behaved in the end like nature, extraordinary nature, a traveller from another star system, but nature all the same. Today it has already rounded the sun and is racing back out into the dark, never to return. And a Harvard astronomer who suspected it might be alien has quietly admitted the odds keep dropping the more we learn. So step back now and look at all of it together, because a pattern emerges, and it is the whole story of this field in a single humbling shape. Watch how every anomaly falls. The megastructure candidates, dust and distant galaxies, Tabby's star, a cloud of shattered comets, the molecule of life on K218b, most likely noise, Oumuamua, probably exotic ice, and 3I Atlas, a comet checked and cleared. Every time, Every single time we find something we cannot immediately explain, and every single time when we look closer, nature turns out to be the answer. And here is the strange truth of it. This is, at once, the most rigorous science humanity has ever practiced, and the most quietly heartbreaking, because it means that after decades of the sharpest instruments ever built, scanning the heavens with breathtaking precision, the confirmed count of alien technosignatures still sits at exactly 0. The telescopes work, the methods are sound, and the sky, again and again, answers with the ordinary. But you have to understand, this relentless deflation is not failure. It is the search working precisely as it should. Real technosignature science isn't about shouting aliens at the first strange light. It's the exact opposite. It's a discipline of ruling things out, of refusing to leap, of demanding that every ordinary explanation be exhausted before an extraordinary one is even whispered. Every anomaly that dissolves teaches us to see more clearly. Every mystery we solve sharpens our tools and narrows the darkness where a real signal could still be hiding, and that darkness is still enormous. We have checked only a vanishingly tiny fraction of the stars on a handful of frequencies, using methods we invented just decades ago. The silence we've measured so far is real, but it covers only the smallest corner of everything there is to search. And as we learned before, an absence of evidence has never been the same thing as evidence of absence. So the hunt goes on. Patient, skeptical, undeterred. But there is a question hiding underneath all of this searching, one that gets harder to avoid with every anomaly that turns to dust. Because what if this endless deflation isn't just scientific caution? What if it's pointing at an answer we've been afraid to say out loud? Not that they're hiding from us, not that they're too far away, not that they're too strange to recognize, but something simpler and far more staggering. What if the silence is exactly what it appears to be? What if we really are alone? And if that's true, if, in all this vast and ancient cosmos, we are the only ones who ever woke up and looked around, then the silence stops being a puzzle to solve. It becomes something we have to carry, a mirror, and a responsibility heavier than anything a species has ever held, because it would mean that the most precious thing in the entire universe might be us. It's a staggering thought that in all the vastness we've searched, the most precious thing might be the one asking the question. But before we accept that we're alone, there's one more possibility we haven't truly faced, and it quietly changes the meaning of that word, alone, completely. Because maybe the silence doesn't mean we're the last ones left, and it doesn't mean we're the only ones who will ever exist. Maybe it means something far stranger, and, in its own way, far more hopeful. Maybe we're not alone at all. Maybe we're just early. Maybe the great cosmic gathering hasn't begun yet, and we've simply arrived so soon that the room is still empty. Let's sit with just how young everything really is, because it's easy to get this backwards. We tend to think of the universe as ancient, worn, near the end of its story. It is not. It is barely getting started. The cosmos is about 13.8 billion years old. That sounds impossibly old, and against a human life it is. But against the future that's coming, it's nothing, because the stars are going to keep burning for a very, very long time. The most common stars in the universe, the small, frugal red dwarfs, can keep shining for over 10 trillion years, not billion, trillion, 1,000 times longer than the entire age of the universe so far. Here's a way to actually feel it. Picture the whole lifespan of starlight, the entire era in which stars exist and shine, roughly 100 trillion years, compressed into a single 100-year human life. On that scale, how old is the universe right now, today, with all its galaxies and all its history? About 5 days old. We are not living in an old universe. We are standing in its first week, a newborn, still in the delivery room. Think about what that means. If life takes a long time to appear, and on Earth it took nearly the whole age of the planet, then most of the civilizations that will ever exist may not arise for billions, even trillions, of years to come. The vast majority of habitable worlds may not have even formed yet. Most of the stars that will ever host a sunrise could still be waiting to be born. When you look up at the night sky, you may not be seeing the crowded aftermath of a long cosmic history. You may be seeing the very opening moments of one, the quiet beginning, before almost anyone else has arrived. The universe isn't a graveyard we showed up to too late. It might be a stage, and we're among the first ones to walk onto it. But that raises a genuinely puzzling question, one that troubled the economist Robin Hanson, the same thinker who gave us the great filter. If the universe is going to host life for trillions of years, and we've shown up in the first tiny sliver of that time, then we are freakishly, suspiciously early. Statistically, it's like buying a ticket to a show that runs for 100 years, walking in and finding yourself in the first 5 days. Why would we be here now and not later when the universe is full? In 2021, Hansen and his colleagues proposed an answer, and it's an elegant one. They called it the Grabby Aliens model. Here's the idea. Imagine that some civilizations somewhere become what Hansen calls grabby. They expand outward from their home world, fast, at a large fraction of the speed of light, and they visibly transform everything they touch, and they last a very long time. Now, a civilization like that doesn't just spread, it sets a deadline. Because as its expanding sphere sweeps across the cosmos, it fills up all the empty real estate, claiming the stars, the planets, the raw materials, before any new civilization that ever gets the chance to be born. And that's the key. If those expanding empires are out there, then you could only ever appear before they arrive, because afterward, all the room is taken. So the model makes a startling prediction. Any civilization that emerges naturally will find itself, almost by necessity, in the narrow window just before the great wave of expansion washes over its region. Early. Exactly as early as we appear to be. By Hansen's estimate, these grabby civilizations are rare, arising maybe once per million galaxies, but expanding at half the speed of light, even that thin scattering is enough. His model suggests they may already control something like 40 to 50% of the universe's volume, and if we survive, our distant descendants might collide with that oncoming wave in roughly 1 billion years, a span so vast that 1 billion years ago, complex animal life on Earth didn't yet exist at all. But, and this matters, this is a model, not a measurement, and it has serious critics. The astronomer David Kipping has argued that the grabby aliens idea, for all its elegance, may not be real science at all, because there's no experiment that could ever prove it wrong. It leans on assumptions we can't test, that these empires all expand at nearly light speed invisibly until the moment they arrive. Kipping calls that a kind of get-out-of-jail-free card, and he points out there are simpler explanations for our earliness. Maybe, for instance, the small red dwarf stars just aren't good homes for life, which would shift the whole picture. The debate is unresolved. Both sides are looking at the same lonely sky and reading it differently. And whichever side is right, there's a colder truth waiting underneath all of it. This bright era of stars will not last forever. For a moment, let yourself drift to the far, far future. Trillions upon trillions of years from now. Imagine you could stand and watch the universe age. The stars, one by one, burn through the last of their fuel and go dark. No new ones form. The hydrogen runs out. The galaxies fade from brilliant pinwheels to graveyards of cold cinders. White dwarfs, neutron stars, drifting black holes. And then, across spans of time so long they break the mind, numbers with more zeros than there are atoms in your body, even the black holes slowly evaporate, hissing away into nothing through a faint whisper of radiation that Stephen Hawking first predicted. From your vantage point, there would be nothing left to see. No stars, no galaxies, no warmth in any direction you turned. What remains is darkness, absolute and permanent, a thin, frozen fog of stray particles, drifting ever farther apart, forever, in a cold that never lifts and never will again. That is where all of this is headed. And against that endless silent night, look back at where we stand, in the first week, in the age of starlight, in the brief window when the universe still blazes with warmth and possibility. Suddenly, our short, bright existence doesn't look small at all. It looks almost miraculous. But let's come back to the harder question, the one we still haven't cracked. Are we typical or are we special? Because two of the deepest ideas in all of science give flatly opposite answers. The first is the Copernican principle. It's named for the man who realized Earth is not the center of the universe, and it has been vindicated over and over ever since. Every time we've assumed we hold a special place, we've been humbled. Earth isn't the center of the solar system. The sun isn't the center of the galaxy. Our galaxy isn't the center of anything. Again and again, the universe has told us the same thing. You are not special. You are ordinary. And it didn't stop there. We learned our galaxy is one of hundreds of billions. We learned our kind of star is common. Our kind of planet is common. The chemistry in our veins is scattered across the cosmos. Every single discovery has pushed us further from the center, further into the ordinary. From that long humbling grows a second idea, the mediocrity principle. If we're ordinary, if there is nothing special about us or our little corner of space, then what happened here, the rise of life and the rise of mind, should happen everywhere the conditions allow. Life should be common, the cosmos should be full. But here's the collision. That principle smashes head-on into everything we saw about rare earth. The argument that our world is a near impossible stack of lucky accidents, and that complex life might be vanishingly rare. Two bedrock principles. One says we're typical, so life is everywhere. The other says we're a fluke, so life is almost nowhere. They cannot both be right, and we do not yet know which one is. And there's a third idea that quietly complicates both, the anthropic principle. It's a subtle thing, but powerful. It reminds us that we could only ever find ourselves in a universe capable of producing us. We can't observe a cosmos that killed us before we arrived. So some of the very things that puzzle us, how early we are, how we survived this long, might not be strange coincidences at all. They might simply be the conditions required for anyone to be here, asking the question in the first place. And then there's an answer that dissolves the entire mystery in a single dizzying stroke. In 2003, an Oxford philosopher named Nick Bostrom laid out an argument that is far harder to dismiss than it first sounds. Consider, he said, a civilization that grows advanced enough to build computer simulations so detailed that the minds inside them are genuinely conscious. Simulated people in simulated worlds who feel every bit as real to themselves as you do right now. If even one such civilization ever exists, it wouldn't run just one simulation. It might run millions, whole histories, whole ancestral pasts, recreated again and again. And now do the arithmetic. If that ever happens, then simulated minds would outnumber real, biological minds by millions to one. So a randomly chosen conscious being, you, reading this, would be far more likely to be one of the simulated ones than one of the rare originals, which leads to a genuinely unsettling possibility that we might be living inside such a simulation right now. And notice what that would do to the silence. In a simulation, the emptiness needs no deep explanation at all. There are no aliens out there because no one ever bothered to render them. The stars are a backdrop, a painted set. The universe stays quiet because beyond the edges of the program, there's simply nothing there. It's impossible to disprove, and that's exactly the problem with it. Skeptics point out that a claim you can never test isn't really science, it's philosophy, and some argue that genuine consciousness may not be something you can conjure inside a computer at all. It's a fascinating escape hatch, but it may be a door that opens onto nothing we can ever check. So step back now and look at the whole tower we've built. Every answer, stacked one on top of another. Maybe we're early, maybe we're rare, maybe we're typical, maybe we're simulated, maybe they're hiding, or dead, or simply too far to reach. Each answer is coherent, each one on its own holds together, and they cannot all be true. But underneath every single one of them lies a contradiction that has never gone away. The same one we started with, only sharper now, because watch what the evidence actually says. Everywhere we look for the ingredients of life, we find them. Water, once thought precious and rare, turns out to be everywhere, a vast, salty ocean sloshing beneath the ice of Saturn's moon Enceladus, another hidden ocean inside Jupiter's moon Europa, ancient riverbeds carved across the face of Mars, and the building blocks of life, complex organic molecules, keep turning up in the plumes of those moons, in the dust of asteroids, in the hearts of comets, drifting even in the cold clouds between the stars. The chemistry of life is common. The raw materials are everywhere. The recipe seems to be written across the whole solar system, and, as far as our telescopes can tell, across the whole galaxy. Every year, we find another world with water, another cloud laced with the molecules that life is built from. The ingredients are not rare, or precious, or hard to come by. They are, quite literally, all around us. And yet the sky stays silent. That's the contradiction, in its purest form. Everything we can measure screams that life should be abundant, and everything we can observe whispers that no one is there. The universe is telling us two opposite things at once, and both of them look true. So what do we really hold after all of this? Not an answer, something better and harder. We hold the true shape of the mystery, because here's what following this whole journey reveals, and it's worth being proud of understanding. The Fermi paradox has never endured because we lack answers. It endures because we have too many, each one partial, each one possible, and not a single one we can prove. That's not a failure of science. That is science standing honestly at the edge of what it knows, refusing to pretend it knows more. And in all that uncertainty, one thing has become solid and clear. The disconnect is real. On one side, a cosmos practically overflowing with the ingredients for life. On the other, a stillness so complete it aches. That gap between what should be and what is not going away. It is the deepest open question our species has ever asked. But there's a final turn to this, one we've raced past in our hurry to solve the puzzle, because this whole time we've been treating the silence like a problem to be cracked, a code to break, a riddle to win. We've asked what the silence is. We've asked what could cause it. We have asked over and over what the answer might be, but we've never stopped to ask the question the silence has been asking of us, whether we are first or rare or alone, or something stranger still. The quiet has been putting a question to us patiently this entire time, and how we choose to answer it may matter more than the solution ever could. That question, what the silence means for us, and what we do with the answer, is the last and the most important thing left to understand. So let's ask it directly. What does the silence actually mean for us? But to feel the weight of that question, we have to do something we haven't done in this entire journey. We have to imagine the silence breaking. Picture it. Tomorrow, an ordinary tomorrow, an astronomer somewhere is watching data scroll across a screen the way thousands have on thousands of forgettable nights. Except this night, something is there. A signal. Narrow, precise, repeating, unmistakably artificial. For a moment, imagine you are that person. Imagine it's you in the quiet room, the glow of the monitor on your face, a cooling cup of coffee beside your hand. You've seen 10,000 false alarms. Your finger hovers over the data, ready, out of pure habit, to dismiss it. And then it doesn't dismiss. It repeats. It holds. And a cold, electric stillness runs down your spine as you realize you may be the first human being in all of history to know, for certain, that we were never alone. After a century of listening to nothing, the universe finally answers. So what happens next? Not what the movies tell you. The first response wouldn't be celebration, it would be doubt, because the very first thing scientists would do is try to prove themselves wrong. Teams across the world would race to rule out every ordinary explanation first. A glitch in the instrument, a passing satellite, a stray transmission bouncing off something in orbit, or a deliberate hoax. A discovery this enormous demands a standard of proof to match, and every anomaly we've ever chased has taught us the same hard lesson. Nature and human error almost always turn out to be the answer. Only after every mundane possibility was exhausted, checked and rechecked by rival teams who'd love nothing more than to catch each other's mistake, would the world allow itself to believe it. It might take weeks. It might take years. The most important discovery in human history would not arrive as a shout, but as a slow, cautious, agonizing accumulation of certainty, until one day there was simply no ordinary explanation left standing. And then, once we believed it, we would face a question we are nowhere near ready to answer. Do we reply? And who, on this entire planet of 8 billion people, gets to decide? Here's where it becomes almost unbearably strange, because a conversation across the stars is nothing like a conversation between two people in a room. Say the signal came from a civilization 1,000 light-years away, which, by the scale of the galaxy, is practically next door. Your reply, travelling at the absolute speed limit of the universe, would take 1,000 years just to arrive, and their answer would take another 1,000 years to come back. A single exchange, one message out, one message home, would span 2,000 years. Think about what that means in human terms. 2,000 years ago, the Roman Empire was near its height. If someone then had sent a message, the reply would be arriving right about now. Everyone who took part in sending our hello would be 40 generations in their graves before the answer ever reached Earth. The people who ask the question and the people who hear the reply would never meet. They wouldn't share a language, a nation, or a world. Contact wouldn't be a conversation at all. It would be a relay race run across 100 human lifetimes. And that changes what a message even is. You couldn't chat. You couldn't clarify a misunderstanding or ask them to repeat themselves. Every word would have to be a message in a bottle, cast into an ocean so wide that your great-great-great-grandchildren, 40 times over, would be the ones to read the reply, if any of us were still here to read it at all. What could you possibly choose to say, knowing the person who answers will be as distant from you as we are from ancient Rome? And that raises a problem we have quietly, dangerously, left unsolved. There is no one who speaks for Earth. You might assume that surely by now we have a plan for this, a treaty, a protocol, some agreed procedure for the most consequential moment in human history. And there are guidelines. A group of scientists drafted a set of principles decades ago, which says, sensibly, that no one should fire off a reply until the whole of humanity has been consulted, likely through the United Nations. But here is the unsettling truth. Those guidelines are not law. They carry no force whatsoever. Nothing binds anyone to them, which means that today, right now, any government, any company, any single wealthy individual with a powerful enough transmitter could choose to answer on behalf of our entire species, deciding alone what the first words of humanity to the cosmos should be. No vote, no treaty, no permission. And the moment that signal was confirmed, governments and scientists and religious leaders would all scramble at once for the right to be that voice, because whoever spoke would be speaking for all of us, forever. Those first words could never be taken back. They would be the opening line of our species, carried outward at the speed of light, long after every one of us was gone, and no one, anywhere, has been given the authority to write them. And beneath the politics, something deeper would crack open. Contact would reach into every religion, every philosophy, every quiet assumption we've ever held about our place in creation. For all of human history, we have been the story. To learn in a single confirmed instant that we are one story among many that would reshape what it means to be human more profoundly than any discovery ever made. But let's set the signal aside now, because it hasn't come, and in its absence the silence pushes us toward a question far more intimate than who is out there. It forces us to ask something about ourselves. What is intelligence actually for? We assume deep down that intelligence is the goal, the crowning achievement of evolution, the thing the universe was building toward. But the cold data of life on Earth is not so sure. Consider the humble bacteria. They appeared over 3.5 billion years ago, almost the moment the planet cooled, and they have flourished, unbroken, ever since. They have survived every mass extinction, every asteroid, every ice age that erased the giants of their eras. They thrive in boiling deep-sea vents, in frozen rock, in pools of acid that would dissolve us. They ask nothing, they need almost nothing, and they will still be here, thriving, long after we are gone. By any measure, evolution actually cares about survival, endurance, sheer stubborn persistence. The simplest life on Earth is the most successful thing the planet has ever produced. Now consider us, and watch the ledger tip. Our great gift, the human brain, is a monstrously expensive organ. It is barely 2% of your body's weight, yet it devours about 1/5 of all the energy you burn. Even now, even at rest, even as you take in these words, it demands years of helpless, vulnerable childhood before it works. It is fragile, it is costly, it is slow to build and easily broken, and it has existed in our form for only a few 100,000 years, a single heartbeat against the bacteria's billions. We have not yet survived even one of the great extinction cycles. We have not yet proven that intelligence is something a planet can keep. So here is the unsettling possibility. What if intelligence isn't the winning strategy at all? What if it's a gamble the universe rarely makes, and even more rarely keeps? A gift of power that arrives long before the wisdom to wield it. A spark that, as we saw, may carry the seeds of its own undoing. From this angle, the silence stops looking like a mystery. It starts looking like a warning, and that warning leaves us standing at a crossroads, facing a choice about how to read the darkness overhead, because the silence doesn't come with instructions. It is a blank, and what we write onto it will shape the entire future of our species. And there are 3 very different things we might write. If the silence means the universe is dangerous, a dark forest full of hunters, or a gauntlet of filters that destroy the young and the loud, then the lesson is caution. We should quiet ourselves, harden ourselves, grow wiser before we grow louder, and think very carefully before we ever call out again. But if the silence means the great filters are behind us, if we are pioneers, rare survivors with an open road ahead, then the lesson is exactly the opposite. We should spread. We should become a multi-world species as fast as we safely can, so that no single catastrophe, no asteroid, no plague, no war, can ever extinguish the whole of us in one blow. Do not keep every ember in one fragile hearth, and if the silence means we are truly, utterly alone, the only minds that exist, then the lesson is reverence. This one small world and the fragile consciousness it somehow produced would be the most precious and irreplaceable thing in all of existence, and our only task would be to protect it and never, ever let it go dark. 3 readings of the same silence, and each one demands a different path through the coming centuries. Notice the strange trap we're in. The silence itself is identical in all 3 cases. The sky looks exactly the same whether the universe is a battlefield, an open frontier, or an empty cathedral with a single worshipper. The stillness gives us no hint which story is true, and yet we may have to bet our entire future on the answer, choosing how to act long before we could ever know which dark we're actually living in. Here is what makes this our problem, and not some distant abstraction. We may be the generation that has to choose, because the silence may not be permanent. Our telescopes are growing sharper every year, our searches wider and more sensitive than anything in history. It is entirely possible that contact, or the confirmed absence of it, could arrive within decades, within a single lifetime, within yours, or the silence may be exactly what it has always seemed, the permanent, universal condition, the fate that every civilization everywhere eventually shares, a stillness that no one ever breaks, because no one ever can. We do not know which it is, but we are the first generation in 4 billion years to hold the tools to ask the question seriously, and, at the very same moment, the first to hold the power to end our own story before we ever learn the answer. Those 2 facts have arrived together, in our century, on our watch, and that is not a coincidence we can afford to ignore. The choices we make in the next 100 years about how we treat this planet and each other, and the immense powers we've unleashed, may quietly determine which of those futures becomes ours. Every civilization that ever silenced itself, if any did, presumably passed through a window exactly like this one, a narrow, dangerous stretch where its power outran its wisdom. We are standing in that window right now, and no one can tell us whether we will make it through. So let's come back, at the very end, to the simplest and most astonishing fact in this entire story. Whatever the silence means, whether we are first or rare or alone or simply unheard, one thing is beyond all doubt. We are here, against odds so staggering they may never be fully counted, on a small blue world orbiting an ordinary star. Matter woke up. Atoms forged in the hearts of long-dead stars arranged themselves, over billions of years, into something that could look up at the night sky and ask what it all means. The carbon in your hands, the iron in your blood, all of it was cooked inside stars that died before the sun was born. You are, quite literally, the universe made into something that can wonder about itself. Every question you have ever asked about the stars was, in a strange and literal sense, the stars asking about themselves, through you. And if it turns out we truly are alone, if there is no one else in all that vast and silent dark, then Carl Sagan's quiet words become the most important sentence ever spoken. We are a way for the cosmos to know itself. That would make our consciousness not a small thing, not a footnote to the grand story of stars and galaxies, but the single most precious and fragile responsibility in all of existence, the universe's only pair of open eyes. And if those eyes were ever to close, if this one small light went out, there might be no one left, anywhere, to notice that the cosmos had gone dark. Return, one last time, to a simple image from the beginning of all this. A single lit window in a house so enormous we cannot see its far walls. For the whole of this journey we've thought of that light as a call, a plea into the dark, waiting for some other door to open, straining to hear an answer that never comes. But maybe we had it backwards. Maybe the light was never only a question. Maybe it was already an answer, because whether or not another window ever flickers to life across that vast and darkened house, ours is lit. Someone is home. Something in the endless dark woke up and lit a candle and looked out and cared enough to wonder who else might be there. And the tending of that light, the keeping of it, the refusal to let it gutter out, may be the most remarkable thing that has ever happened in the whole silent house. The silence, in the end, is a mirror. Stare into it long enough, and it shows you both truths at once. How unimaginably small we are, adrift in a cosmos that does not answer, and how staggeringly rare, how precious that we are here at all to feel the smallness. So we keep listening, not out of loneliness, but out of wonder, patient, humble, awake to the vast and waiting quiet, and to whatever it may someday hold. And perhaps that listening, more than any answer it could ever give us, is the thing that truly matters. For this whole journey, we've talked about a single lit window in a vast, dark house. One small point of light, calling out into rooms it cannot see, waiting for an answer that never comes. But somewhere along the way, I stopped picturing that window as humanity. I started picturing you, right now, wherever you are, a quiet room, a screen glowing softly in the dark, the world gone still around you. That's it. That's the window. You are the small, warm, impossible light that a cold and silent universe spent billions of years learning how to make. Not a bystander to the mystery, a piece of the mystery itself, a fragment of the cosmos that somehow woke up and looked out and cared enough to wonder who else was there. So thank you for staying awake with me through all of it, for being curious, in the quiet, when you could have been anywhere else. If this journey meant something to you, a like and a subscribe are how you keep this small light company. More quiet journeys into the dark are coming. I hope you'll be here for them. For now, rest. Close your eyes. The dark is nothing to fear tonight. Just keep your window lit. Someone, someday, may be looking for it. Sleep well.